discussing today on the machine learning, and we will be covering the introduction part. So, agenda for today's lecture would be, I will be talking about what exactly machine learning is, why exactly this machine learning is required. I would also talk about the traditional programming approach and the machine learning approach. We would also talk about the entire life cycle of the machine learning, and also we would be talking about the types of learning, right. So, to begin with, let us talk about what exactly machine learning is all about. So, I will take a very definition which is well known by Tom Mitchell, which was given in 1998, which says that machine learning is a computer program, I would say, which is required to learn from the experiences E. So, the important term over here is experiences E, which we often would talk about in terms of training data. We would also talk about experiences E in the form of the examples available with us, right, with respect to some specific task T. So, obviously, when I am talking about solving a problem, there has to be some task which has been given to me. So, for a given task, I have been given what? The set of examples, experiences, right. And then we also talk about another term which is called performance measure. So, I have a task, I have a set of examples, and based on those set of examples as the training data, I have to learn, I have to make my system, I have to make my program learn, so that it can eventually learn to solve that particular task. But the major perspective of this entire scenario is that it must perform this task, it must learn what is expected to learn from the given examples with some performance measure. So, there has to be a performance matrix that measures my performance, that measures my the tasks which have been given to me, and this performance should be measurable and also must improve with the experiences. What it means that as the experiences would keep on increasing, or in other words, as the data would keep on increasing, right, my learning, my ability to improve this performing task should also increase. I should become more and more proficient in solving this particular task, and that is what we say that it is something where we talk about a term called learning, right. And learning always happens automatically as more and more experiences gathers. So, I need not to just go back and again program those things again. I doesn't need to go back and again rewrite those rules. So, we will talk about what exactly what I am talking about in more details. So, the examples could be many. For example, I have given a task of, suppose, playing checkers, right. So, computer program has been given a task to play a checkers. So, what exactly can be done? So, obviously, here the experiences would be in terms of what, that it plays the checkers game and again. So, that would accumulate the experiences, that would again accumulate those set of training examples. It would learn which move to go so that it can win, and it would also learn which move not to take. So, that is where the learning was happening, right. And over the time what would happen, that it would start winning more games as it would make mistakes, and it would learn that where to do, what not to do, which of the moves should be taken. So, in a way a learning is happening. That is what exactly happens in natural way as well, right. So, the task is still the same thing, that is, you have to win that checkers game, the task remains the same, right. And if the computer keeps improving as it plays more, so obviously what is happening is it is going to do learning, and that is what exactly machine learning is all about, right. We will take some other example as well. For example, I have been given a task of recognizing the handwritten digits. Now, again over here, how it learns? It is simple, like it initially the system or the program would be given the number of digits which are handwritten. I would give enough examples to it. For example, I will give a number of ways in which a 1 has been written, right. So, the computer is going to learn from in different ways that 1 can be written. So, in a way it is trying to learn how the 1 can be recognized. Similarly, rest of the digits would be given. So, it guesses them, right. In the same way a teacher is there, So, data set, so we have been given the labels. So, one has been written different handwriting ways and its label is also given. So, it guesses them, right, the way teachers exactly helps us, it tells us the correct answer every time. So, it updates itself to reduce those mistakes. So, every time I make a learn, so it is simpler as if like we are making a child to learn something. So, during its learning phase initially it would make mistakes, and eventually with more and more examples and more experiences it has been given, the time would come when the system would start making those mistakes less and lesser, and that is where we say that the algorithm is learning. And that is, once algorithm gets learned, we can apply that algorithm, we can apply that system to solve the realistic problems, right. So, what exactly more image it says, more accuracy and the better performance, that is what the bottom line is. We will talk about machine learning in more details. Actually, this particular term was coined by Arthur Samuel and in 1959. It is quite a old time. It is not at all a new concept at all. So, he was an IBM employee and he is considered to be the pioneer in the field of computer gaming and artificial intelligence. So, machine learning is actually a sub branch of AI that basically is concerned with the development of algorithms, right, which allows a computer to learn from the data and the past experiences. That is what we were talking in the previous slides. So, data becomes the oil over here. The major component is the data and the experiences, and this data and experiences actually forms the training data based on which the program is going to learn on its own. On their own means, so once I have written the algorithm, so the data might increase, that experiences might be added, new experiences might be added. I should not be going back and rewriting those rules. Once a program is written, my job is done. So, I just need to retrain on the added examples or the added experiences that comes a long way. So, ML systems learn from the examples and improves on their own. That is the key aspect of learning in machine learning, right. The programs improve the performance as they see more and more data. So, as the experiences and data increases, they are improving and they are improving its performance, and performance is always measurable. So, with the time you would learn that how the different algorithms are evaluated in terms of different metrics. So, machine learning actually uses various algorithms to build something called mathematical model. These mathematical models are actually nothing but they are the functions that tries to map from the input to the output. With the time we would learn and talk about more about this in this session, and making the predictions using historical data or the information, right. So, let us also talk about the key difference between the traditional programming approach and the machine learning approach, right. So, when we talk about traditional approach, just think about, suppose you have been given a task of telling whether a given number is prime or not, right. So, in this case I know the entire logic behind it, under what circumstances, under what rules a given number is declared prime or not. So, I know the steps from 1 to n, right. So, every time I am going to run those steps from 1 to n with correct data, every time I am going to get the correct answer. So, this is a typical approach where I would give my data definitely, right. I would give my input, I would also give my program, right. Data over here is the inputs which I am giving right now, right, and the program. So, I need to give a right program obviously, and I need to give the correct input. So, data over here is just the inputs, right. So, program and the input is the only things or which goes to the system, and once this goes, you are expected that every time this inputs would be correct, it would always come up with the correct output. So, you have given what is the input, we are given the program, and you are expecting a correct output. Now, this approach is a little different in machine learning, right. So, machine learning would talk about what you actually give the data, and this data is the form of examples. It can be with labels or without labels, right, and we actually are not giving any program. Why not program? Because still we does not know that how to go from input to the output. I does not know how to form the rules, and that is the problem in many of the cases, right. So, for example, if we are given a task of recognition of digits, so I does not know how to recognize the digits. There is no defined rules, there are no defined algorithm for it. If there had been a defined algorithm, obviously everyone would have followed that set of rules, that followed that set of algorithm, and have got and solved the problem exactly in the same way. But that is not the case in most of the problems, like weather forecasting. There are a number of cases where you does not know the rules, and that is where the role of machine learning and similar kind of technologies come into play. So, what you are giving over here is the data from where I am expecting my system to learn from input to the output. How? Because that function needs to be, that function is not known to me, that rules doesn't is not aware, I am not aware of those rules, right. So, I am giving the data and I am giving the output, expected output, right. I am not giving the rules of the program at this stage in machine learning. Now, based on this input and the output, my system or my algorithms would try to learn that function, right, the function of input and output, and that is what is the output. That function would be the output, that function would be, in a way, would be called as a program, or we can say a model, right. So, that is the basic difference between the traditional approach and the machine learning approach. So, in machine learning you give the examples instead of rules, and the computer learns those rules by itself from the data. So, that is the basic approach, whereas in traditional approach we write the rules, that is a program, and the computer follows them. So, wherever, if you want to add, say suppose in prime number programs, you must have written the input should be only integer numbers, and at times suppose you want to make a change and want to ensure that you can also take real numbers. So, obviously you will go back and change that program. But in machine learning, once you have written the thought process, once you have given the data, right, you would not change the algorithm or not change the program, rather you would give more appropriate examples, and it is expected to learn and change its learning or improve its learning through those added examples. So, that is the basic difference. Okay. So, actually what is happening is it creates its own rules based on the experiences, and during the testing obviously the model would predict using those learned patterns, right. So, if we go and see little bit of mathematics behind the scenes, so machine learning is nothing but basically about finding a function, right, exploring a function f that maps the input, right, the input was given to us, right, in form of training examples, and the output again which was given. So, I am trying to learn, and since I does not know how to reach from the input to the output, so I am trying to approximate a function mathematically, that is y is equal to f x, and that function can be very complex, it can be linear function, it can be non-linear function. So, if you see statistically, it is nothing but a mathematics. So, it is approximation of the function, it is a learning about that function, which may take a lot of time, which may take a lot of efforts, which may be very complex, which may be a simple function. So, it is about, in a nutshell, machine learning is about learning that function, right. So, we do not know the exact function, I have told you. If we knew that function, I would have rather written a hard code program from 1 to n steps, and I would have run those algorithms again and again with the correct inputs. That would have been the conventional approach. Here I did not know the rules, I did not know how to solve the problem, that is the reason I am trying to approximate with function. And when you talk about the approximation of the function, there cannot be a single method, there can be different methods, right. There can be different ways in the data would occur, there can be different ways in which the algorithm would like to learn from the data, and we will come to that aspect later on. But definitely there cannot be a single methodology, there cannot be a single method of learning from the data, and therefore the machine learning algorithms are quite a many. So, the algorithm learns it from the example, that is the bottom line. Okay. If I gave an example of, suppose you are given a task of say suppose house price prediction, for example, right. So, where you would given an input and output, input would might be consisting of, say suppose the house area in sizes, for example, square feet, it can be the any different sizes would have been given to you, right, and you would be given also what the output. So, this would become the training data. So, it would give him number of examples in terms of the house area based on which you are given the price. So, what our system or the algorithm is expected to learn based on the size or the area how the price varies. So, with the time, if the function would be approximated correctly, so I should be able to create a function of input to the output, and that is what is the task that normally most of the machine learning algorithms actually are given, right. So, it may be something like the higher area and higher price, it may learn that kind of rule. So, how it is going to learn, what kind of pattern it is going to learn, that would precisely would depend upon the data, the kind of data which is given to us. The more data is given to us, the quality data is given to us. So, you are expecting to learn the correct rules, right. If you do not give correct rules or correct data or lesser amount of data, you do not expect the algorithm would be able to catch the right mechanism or the right rules out of it. So, one of the rules that it might capture is like higher the area, higher the price, right. So, now if someone asks for a price, suppose what is the price for x square feet in the house, which was not in the part of the training. So, since it has learned to give a value, to predict a price based on the size, based on what it has been trained on, it is expected to give you an outcome, a value in terms of the price, right, if it has learned correctly. So, let us now talk about something, the key challenges in machine learning. So, see, by this talk whatever we have talked till now, we really do not know the true function, that is what we were talking about. So, we may test many algorithms to find the best approximation, that is what we were talking about, because if we knew that function, if we knew how to reach from the input and output, I would have rather written a hard coded algorithm or hard coded steps, the way we do it in classical algorithms. So, here the different machine learning algorithms, like for example linear regression, SVM, neural networks, with the time we would learn about that. So, there would be different machine learning algorithms, they would assume different shapes of the function, they would learn differently based on the problem, the data, right, and that is the reason why we need different algorithms, right. So, again if I take an example of, suppose I have an input and I have an output, and the input can be suppose image of a cat, and the output would be tagging or a label called cat. Similarly, I could have the house features, right, and the output could be the market price, for example. Similarly, it could be input could be sensor data, and the output could be whether machine would will fail or not, right. So, now, these relationships are difficult to predict. For example, in case of a cat, recognition of a cat, there can be many shapes of the cat, there can be many sizes, colors, and there can be number of ways in which the cat might look. So, there can be many challenges behind it, right. Similarly, for the case of house prediction, the prices may depend on many factors, location, demand, condition, right. There can be many aspects, right. There can be many features on which the house price might be dependent upon, and it might vary, right. Similarly, when you talk about sensor data, there can be many hidden factors. So, I mean the algorithms, different algorithms are written to work differently, and that is the reason I need the different algorithms, different ways to actually learn the rules or to formulate the rules or learn from the data. And that is the reason I would say it is a challenge, because the data needs to be perceived, needs to be handled in different ways, and that is the reason we have multiple algorithms. Let us also talk about that when actually we would apply machine learning, right. It is not that machine learning would be blindly applied for whatever given problem is with us, right. I will give you in a very simple scenario. For example, human expertise actually does not exist when we are navigating on Mars. So, that is a problem. Suppose I have to find something, I have to navigate on Mars. So, humans probably have not gone on the Mars. So, we does not have experience, we have not collected those experience. So, humans since have never driven on the Mars, the conditions would be unknown there, right, the rocks, the slopes, the dust storms over there, right, and the rovers actually are expected to learn that how exactly to understand those conditions, how to what are the conditions, what are the slopes, what are the dust storms over there. So, rovers have not got that opportunity to learn, right. So, that is where the tagline over here is that when I does not have enough human expertise, I does not know, or the conditions available with me are unknown to me, right. The example was navigating on Mars. So, that is one area where, since I does not have enough experiences, I does not have enough training examples maybe, right. So, that is where the need of machine learning can be thought about. Another approach could be where the humans can't explain the expertise, right. So, for example, biometrics. So, in biometrics, you know what exactly it is meant for, but we know like how to do the things, but we can't actually write them into rules, right. If I talk about how to recognize a person, I know how to do it thanks to the complex brain neurons that I have got, and the coordination of hand and eye, right. So, thanks to that, but if someone asks me to write set of rules, I won't be able to do that, right. So, that is one of the areas, or that is one of the places where the human expertise can't explain, or humans can't explain the expertise. That is one of the areas, like an example of biometrics. Similarly, models must be customized. For example, you talk about personalized medicine, like two patients with the same disease may respond differently, right. So, obviously, again it is something which is very unknown, right, to me. The models cannot, I cannot write a model for keeping in view of a single person or single genetics of a person, right. So, these are some of the major areas where the machine learning may be required, and the approach of machine learning would be good enough to get some solutions in the similar way we humans are good at solving such kind of problems.